Okay, welcome back. Welcome to our final time segment before lunch. Lunch will be in the next room, and it will be an American-style lunch rather than the Chinese style that we had yesterday. So, we have several topics left over because, as expected, none of the ones that we talked about before the break lasted 15 minutes. That's good news. Some of these I put on there because I was curious about some things, and we might be able to dispense with them quickly. So when we talked about TCP priming, there were two bits of inclarity. I'm going to head up to the podium for this part. First has to do with some terminology that Akira and I introduced in the response size draft about 7 years ago when that draft began its life. I think it may be the oldest living draft in IETF history. And the distinction was between what we called soft truncation, where not all of the glue, the address glue, would fit in the additional data section, but the TC bit was not set because, in fact, all of the necessary response data was present, versus hard truncation, where the data would not fit into the authority section for a referral or into the answer section for an answer, in which case the TC bit will be set. Now, in this room, I think everyone knows that if the TC bit is set, that is an indication that you did not get everything, and that if you really want everything, you have to retry with TCP. The first version of Song's draft on this topic suggested that we just use TCP from the get-go because the cost of a soft truncation event is that you won't have the updated addresses or complete addresses for all of the name servers. And there is really no guidance anywhere in the protocol that says if you get a priming response and it doesn't have a quad A, you should do a separate query to see if there was a quad A that you didn't get, for example. So you could end up with a name server that only uses the data that was in the priming exchange, and if something wouldn't fit, like one of the V4 addresses or one of the V6 addresses, or perhaps several V4 and V6 addresses for some name servers, then you'll just never try that protocol with that name server. So there is a draft currently expired, but it's been around for a while, that talks about the TCP priming exchange, and when Andrew or Paul mentioned it yesterday, they said simply that it, quote, has some problems, unquote. Like, for example, the first sentence is factually wrong.
Didn't say that.
No, that's what I said. I ended the quote. So what I want to make sure that we take away from Song's presentation is that if you do a EDNS-based priming query and you do not get all the data, you might not know you didn't get all the data because the TC bit will not be set. So that's the problem statement. And his suggestion was just try TCP because with TCP you will always get all the data. I am still generally uncomfortable with that, but I recognize that that may be one of the many uncomfortable things I just have to get used to in the new DNS as we move forward. Nevertheless, that's where the direction of that draft is going to go from here, and I don't think that was made completely clear yesterday.
I'm sorry, which draft?
The Song draft on TCP priming. Now, we have, of course, a lot of alternatives, and one of the things that I believe Andrew said during the Q&A from that discussion was, why are we sending additional data at all? And I wanted to make clear to myself what Andrew meant by that. So I wanted to use this time to sort of follow up there.
That was me.
Oh, Hoffman.
So, and
Can we get this man a microphone? Here, take mine.
As we were discussing yesterday, we actually, in our discussions, specifically one of the things that was different between Warren's and my draft and your draft was priming query. You know, ours doesn't really have a priming query issue, yours does. So we were wrapping some conversations together and of zone transfer versus priming. And I believe I said something that was just like completely wrong because I was talking about the wrong query. And that's actually one of the reasons why, when I started yesterday, I said, let's be real clear on what we're speaking about, because for Warren's and mine draft, priming query doesn't matter. For your draft, priming query matters a lot. And then afterwards, there are still zone transfers happening. So,
All right.
yeah.
So
So obviously, in a priming query, you need to get A records back. Now, the other part, and I think that's where you were having the issue, the other part that was alluded to in the questions for your draft about DNSSEC comes to what I think you're about to, what the next topic we're having anyway, so we don't need to go there. But on that, if you've done a zone transfer, and now you're going to, in fact, chase down those answers, and even if you're a validator. And so I'm giving you the
Yeah.
lead here for the next topic.
Yeah, thank you for that. But again, I want to make clear that the reason that the song draft exists at all is because you might get incomplete results that you cannot detect the incompleteness of when you make a priming query without TCP. And this would be true even with eDNS, no matter what your buffer size was. And so there may be a reasoned proposal here that has a chance to reach consensus that we really should just use TCP when making a priming query for this reason. I'll give you a little bit of history before I've launched the topic that Hoffman has picked up here. In the old days, there were, I think, 7 root servers. We eventually added, or maybe 8, but we added some one day because Bill Manning realized we were using a great deal of space in the in that priming response to give a complete name, a distinct name to each root name server. Right? There used to be something called ns.isc.org and ns.psi.net and so forth. And so to completely enumerate all of those names meant that those literal strings had to be present in the response, and that took space. So Bill Manning had the interesting idea that if they were all single-letter names having a single suffix, which is rootservers.net, that the text rootservers.net would only need to appear in the packet one time, and that the other 12 times, or many more times if you think about the A records and so forth, would all be just pointers to that one common suffix. And on the strength of that, we got the root priming query size down so low that we realized, gee, we could add some more name servers here. And it was a different world then. I'm not totally sure that ICANN existed at that time, but there was in any case there was nobody around at layer 9 to say, oh good, we've got new root name server letters to hand out. Let's see, what kind of a political chaos we could make out of that. Instead, John Postel said, well, I know the right people that ought to be getting these other letters, and so we're going to, one of them went to RIPE and so forth. One of the concerns at that time was that negative answers from the roots included a complete RFC 2308 proof. In other words, the SOA was there, and the NS records were there, and of course the Q name was there. And so we were reserving space in a pre-eDNS world, in other words, 512 total octets. We were reserving space for the Q name in the negative answers, as well as a complete copy of the NS record set. Now, the additional data didn't need to be there, right? For a negative answer, you need the NSs. You don't necessarily have to have the additional data. Truncation at that level doesn't bother you at all, even soft truncation, right? As long as the NS record set was complete. But eventually, we realized, this NS record set that we send on these negative answers is just burning space on the wire. Let's stop sending it. And so a negative answer from the root servers today doesn't even include that. So meanwhile, we invented eDNS so that we could go beyond the 512 octet limit. There are some real problems with eDNS having to do with fragmentation, and if we have time before lunch, I will explain more about what I think needs to be done there. But it's not root specific, so I don't want to burn time on it if there are other topics. Anyway, we created more space, but then we filled that space with Quad A records. And Quad A records have an awful lot of 0 octets in the middle of them because almost nobody uses all 128 bits as non-zero. So there's this colon in the middle of the printed expression representing a bunch of zeros that are sent literally on the wire. So these are huge. And so even though we increased the effective size by using eDNS, we also increased the use of that space. And so now, the world as it is today, a priming response containing a complete additional data section is a little over 700 bytes. It will not fit without eDNS or TCP. And interestingly, that includes no signatures. The NS records at the top of a zone, at the apex of a zone, are signed by that zone's key, but the NS records at the bottom, which delegate to, in this case, TLDs, but to, in general, that delegate to child zones, are essentially glue. Those are name server glue records because they're not authoritative in the parent. They're only authoritative at the apex of each child, which means that there is no signature on any of the NS records for, say, COM, as reported by the root name servers. I have gone back and forth over whether I think that was a good design, but it creates some good, it has some good impact and bad impact, and it's something we can still argue about, perhaps today, if you wish. None of the address records are in the zone. They are in a different zone. They're all in the rootservers.net zone. Rootservers.net is not signed today, and it wouldn't really matter if it were signed because we don't validate the address records that we receive in a priming query. Just as we don't have a protocol by which we're required to look them up, we don't have a requirement that they be validated. And the reason DNSSEC works that way is simply because if the address is wrong, you're going to be talking to a server that doesn't have signed data. So there will be no opportunity for the wrong server to somehow inject poison, and that was the problem statement for DNSSEC. We need to continue our discussion about zone hash. We need to continue talking about whether the NS records at the bottom of a zone should in fact be signed by that zone's key. We're probably not going to talk about those things here because I think we have enough more important things to use our remaining time for. But I wanted to get everybody on the same page with regard to where we are and how we got here, because there are a lot of opposing forces, creating tension on this, and the ball is moving around as those forces get stronger and weaker. Song, have we, in your opinion, correctly summarized the TCP priming draft? Do you have anything else you want to say to clarify your remarks yesterday?
Yeah, the first issue focus, of course, the V6 address root information. So the second one and third one is a trivial one. Need more discussion later. So maybe next version I will focus on this. The first one as my problem statement, and we will figure out how to modify the use of TCP, not add the previous to used by default. So I will evaluate the different risk of performance of each modification. Yeah.
All right, thank you. I think you know that everybody in this room would be willing to discuss this with you. And so if you wanted to have a smaller circulation of your next draft before it hits the entire mailing list, where people are sometimes pretty harsh, including me, almost anyone in this room, I think, if you asked them to review a draft, would tell you their thoughts about it. Okay, so let's talk about x.rootservers.net. I mentioned that there are not signatures for the root name server names at present. The root name server addresses. They're in an unsigned zone called rootservers.net. Now, there's no problem signing it other than figuring out who you need permission for, because it's obviously part of the root infrastructure, and so there's probably the chairman of this and the subsecretary of that would have to have a meeting. But eventually you can get over that part, and the rest is just a matter of signing it and making sure that the .NET zone has the DS records and so forth. So there's no difficulty signing it. There's a difficulty in being motivated to sign it, because the root name server is not. It used to be that all the root name servers were also authoritative for root servers.net. Right now they're not. Some are, some are not. And the ones that are not would not necessarily have those signatures, because right now the address records are zone glue. In other words, they're in the root zone as transferred, but they're not signed by it, and they are all below NS records. In other words, the name rootservers.net or x.rootservers.net is below the .net NS record. And so there can be no signature in the root. So most root servers wouldn't have signatures to send, even if that zone were signed, unless we made them all be authoritative for it again, which is yet another political battle that we'd have to fight. So those in this room are wary of political battles. We would prefer to solve problems that are measurable, and where the right answer can be recognized on technical or engineering merit rather than by political merit. And I think that's a strength of ours. So let me say that if we were to change the location of these names, so that instead of a name being x.rootservers.net, it was simply x.root, and root were a new TLD, but undelegated, so there's no NS record at .root in that model, then these would all become in-zone names. So you would have f.root, c.root, etc. And again, there is no delegation point at .root in this model. This is just in-zone data can have dots in the owner name. You don't have to have an NS, a delegation point at every dot that you see in a name. Think about the in-adder tree if you don't understand what I'm talking about. So in this model, the root zone would be self-contained. It would have no external dependency on this other zone, rootservers.net, that was not signed and not served by the same servers. And in this model, a priming response or any other response from the root where the address record was present would include a signature for that. I am intrigued by this because we're not currently facing a big size problem. We're already at the point where you have to use EDNS to get a complete response and to get a complete priming response. And we're already talking about using TCP for priming responses. And so the size of those signatures is not the concern that it would have been 10 years ago. And so I wanted to bring that up so that we can have an interesting discussion about the pros and cons. Now let me say, creating a new TLD, like .root in this example, is a political minefield. It requires that you go have a lot of meetings with a lot of people who don't understand what you're talking about, and it's painful and it takes a lot of time. Nevertheless, if the technical community had consensus that this name should be reserved, and I'm fairly sure that ICANN already would not allow a GTLD called .root to exist because they would treat it as ambiguous in some way. So if we asked for a reserved top-level name of .root, we could probably get it. It would probably only take a year or two, maybe. And so I'd like to not talk about that. The difficulties of getting it approved by the people whose permission we would need are kind of beyond scope. A number of us are going to be asked about it or be in the room when it would be argued about, but I don't want to argue about it here. I'd just like to argue about the technical merits and demerits of it. Andrew, your hand has been up.
I'm still having I've been trying to work through exactly the argument about rootservers.net, because I know historically what people said about this, but it always struck me as a little funny, and so I want to step through this very carefully to make sure that I understand it with everyone's indulgence, because I'm not sure that everyone understands this. But if everyone understands this, you can all just shout out, "Shut up," and I will. So net is signed, and the root is signed, and so we've got a secure delegation. If we accept the trust anchor, we've got a secure delegation from the root to net. So if we sign rootservers.net, we could in fact validate data inside rootservers.net. So what is the problem that not all of the root name servers are authoritative for rootservers.net? I don't understand why that's a problem.
It's not a problem, it's a difference. Some root servers, since they are authoritative for this, will be able to include authoritative data, including signatures, in a priming response. Others would include the unauthoritative data that was at the bottom of the root zone and would not include signatures.
Right.
So you would get a different priming response depending on which root name server you asked. That's not true today. That's not a problem. That's just something we need to talk about.
Okay, so one thing that we could do, I mean, I agree with you that we don't want to talk about the politics of getting a new top-level domain versus the politics of getting the rootservers.net zone signed. But stipulating that both of them involve political things, we've got a working system, and so if the idea here is that, well, we could validate, we could specify as part of the probably not the current priming query draft, but an improved priming query draft that didn't say, for instance, don't ever use TCP, and instead had some other thing, then we could include in it, and you should validate this. And then if you got a priming response from a root server that was not authoritative for rootservers.net, you would just do the normal thing that you ever do for validation, right? So you would follow the delegation, and you'd have to do bottom-up validation, of course, because you'd have to get to the final thing that actually gave you the signature and then work your way back up. But we already know how to do that. And so it seems to me actually that we could just say you should validate this thing after all. We were wrong in the past. We thought, you shouldn't bother because, well, you're never going to be any worse off than you are in that case anyway. What are you going to do? You're going to say, well, you're broken. But if people are, regardless of whether we think it's a good idea for people to do this kind of stuff, if people are in fact, going to keep their private copies and so on, then you might as well say, well, yes, you ought to validate this thing in order to get yourself started. And we could give that advice, and then that would be a reason for the root server operators to get together and say, yeah, we really ought to sign this rootservers.net. I think the pressure historically has been don't bother because nobody cares. But if suddenly people cared, maybe there would be pressure in the other direction.
So before we go to Warren, I'll say a couple of things. First, changing anything you want to change about rootservers.net is almost the same painful meeting with almost the same people as you would have adding a reserved TLD called .root. And so it would require, among other things, consensus in the technical community, and then a lot of explanation and air miles in the non-technical community to sell the idea.
So I agree with that, but except that there is the fact that the top-level domain space right now is closed, and so we could, there's lots of different possible paths that we could follow there, but just stipulating that that's going to be politically fraught no matter what. There's the operational fact that way we don't have to change any name server names. So I don't think there's something to recommend one way or the other in this, but regardless of what we did, there wouldn't really be. The problem is not really that the same name servers don't have all of this. It's really just we haven't told anybody to validate it. Validation would work just fine now, I think.
So since I was in the room last time, we had an argument about which servers would not, should, and should not serve rootservers.net. And I was in the room last time we talked about whether it should be signed. I'd like you to take my word for the fact that the order of magnitude of pain of adding a .root TLD reserved name is the same as any change we might like to make to the rootservers.net zone as far as who serves it and how.
I'm prepared to concede that.
Okay.
What I'm trying to say is that doesn't matter.
I know, but
Okay.
I want you to concede that so that I can get to the real point here, which is that administrative pain level, I see Warren's hand up.
I was pointing at the root servers.
Brad was also in the room last time we had one of these painful conversations.
Well, just a few corrections. I believe every root serves rootservers.net.
Do we now?
Yeah, and that's, every
Okay.
root
Thank you.
has been
Thank you
delegated.
for that.
It's in the NSA.
All right, so if you will accept on faith my assertion that the pain level of a new reserve TLD for this purpose is about the same as the pain level of trying to sign rootservers.net, then I would say let's talk about the technical difference, which is if you are a new name server, which is one of the biggest reasons people have for sending a priming query, and you get a response back, in the current situation, you'll get, if they're all indeed authoritative, you're going to get signatures for all of these names, but you're not going to have the signature for .NET. So you'll be querying for that. So that means priming has an automatic cost for DNSSEC validators that is more than one transaction. And in this other model, you would receive signatures that were signed by the trust anchor that you have. So that is a technical difference rather than an administrative difference. So now let's move to Warren.
So I'm happy to admit that I'm not the smartest bunny. And I think I might have missed the whole thing on what problem we're actually solving or having. Sure, when some things start up, maybe they don't get a full priming query, with all of the required information. But they get most of it, or at least enough of it that when I open my browser and search for pictures of kittens, I get pictures of kittens. So what's the actual real problem that we have and that we're trying to solve?
The problem statement for this, in my opinion, is complexity and coupled dependency. The fact that something else has to be correct in the internet beyond just the root, because the root is not self-contained in this way, has in fact always bothered me some. The fact that it's possible right now to poison various name servers by intercepting queries for this unsigned zone, rootservers.net, bothers me. There are several weaknesses, and I just want us to consider whether it would be better to have everything signed with that one key and receive everything you need in one response and then get your real work done. Because the reason we didn't do this before had to do with packet size. In other words, it seemed like a pretty good idea to put the root name server names in a different place or to have them signed or not. We've made a number of decisions over the years based on the size of that priming response, and the minimum priming response is 722 octets right now. So I'm just saying, let's go back to first principles and say, if we had it to do over again, would we wind up here? Brad?
Just to add to that, I think, just to add some color, I guess. I don't disagree with your statement saying that the reason we didn't do this was because of packet size, but I think that dates a long time ago. This topic has been talked in rooms I have sat in numerous times. This is not a new topic, and essentially where it's always ended up with is what was the value of going through the effort to sign rootservers.net. And I would love to hear that from people here, what they think the actual value, what you're really getting out of it, short of more DNSSEC adoption. But I would kind of argue the point that making changes to rootservers.net is as hard or as filled with as many minds as getting a new TLD or a reserve TLD is of .root. I think we've defined the process for making changes to rootservers.net. We did that when every root was added to the delegation, and if we wanted to make changes to it, I think it's something that we could do.
Okay. So some of you are members of various secret handshake societies that meet behind closed doors and talk about things that are not public information. Some of you are not. We did not want to make this a closed door meeting. I'm not going to ask for a show of hands, but I am aware personally of a half dozen of you that know what I know about a current poisoning attack that relies on rootservers.net being in a different zone and a subdomain of .net. And I'm not at liberty, unfortunately, to talk about the details, other than to say some of you know what they are. And in the case of a non-DNSSEC validator, signing rootservers.net is not going to solve that problem, whereas moving the root server names into the root zone would solve that problem. So I'm going to say that that's evidently all I can say on this topic right here, because the actual use case is not public information. So I will get together with those of you who know what I know and see if I can convince you that this is one approach to that problem.
Paul?
Yes, sir.
I'm half in that group. But you said, and again, I want to be real clear, you said moving the root servers into the root zone would solve this problem. Would signing rootservers.net also solve the problem?
For
validating resolvers.
For validating resolvers who knew that they needed to go validate these glue addresses, yes.
Yes. Okay. Good. Because you had only mentioned one of the two, and I
Okay.
had thought that both of them were equally valid.
Yes.
Yes,
And
okay,
so
great.
I agreed with, I think it was Andrew, but whoever said, why are we exerting effort to protect people who don't want to protect themselves? That was a comment yesterday about unsigned, protecting people who didn't sign their zone and so they didn't have DS records and so forth. And I do agree with that. On the other hand, I am mindful of the long tail that DNSSEC has already had. We worked on it for 16 years before we got the root signed. It's been another year or two since then, and Jeff says that we're still below 50%. So to the extent that a lot of the internet is not using DNSSEC, and some part of it may never use DNSSEC, I would be willing to bend over a little bit to help those people, because not being willing to run a validator could just mean that you don't want to be in the position Comcast was in the day that NASA broke their DNS signatures. So it's a cost-benefit thing less than a idealism thing or a commitment thing. And if somebody is making the cost-benefit determination that DNSSEC is not ready for them yet, I would be willing to do something to change the metadata surrounding the root zone to protect those people, at least for the next 5 or 10 years that it takes DNSSEC to become ubiquitous. So we have, yes, sir.
So I agree that there are technical differences. I'm not somebody who has to sit in any of those meetings. I'm very happy about that. I think I sort of like what Andrew had said earlier about where the difference between the two of them is, one is we are saying, using no new technology, no new names, we're getting the same value by signing rootservers.net as compared to a new TLD. And I will strongly disagree with one of the things that you said earlier, which is one of them would be approximately the same amount of grief and time as the other. That's unpredictable. I believe that given a statement of there is value here, and that's what we're working on, that in that world where there's agreement that there is value, a solution that takes nothing new protocol-wise, and I do believe that all the names, all of the special names in the root are protocol changes, and that's the way the IETF has decided to pretend to work on them. No offense, Suzanne, but that really is, that because of that, I would say the sign it will be more attractive as an answer. I'm not saying that I can say that it will go faster or be less work, but I know that it would look that way. And Suzanne, do you want to talk about the process? I mean, just to negate what I just said, do you want to talk about the process of adding a new route? You know, you're supposed to be doing that document, or you did the document for the IB, the liaison statement that hasn't come out, but
I'm not sure I followed what you said, so you'll have to.
so you were author of a liaison statement the IB was going to make. Oh, I'm sorry.
The IB Shepherd for ICANN was. But
So I
backtrack
thought
a little
you.
further for me. What is the significance here?
Well, the significance is, in fact, since the IETF has had a large list of names that have been blocked, and therefore Paul is saying, you know, whole world of pain and a lot of time. Is this about to burst open? And in fact, it's easy, because if so, then I would say, never mind. .root. I fully agree with Paul that .root is something that ICANN would not say, oh, we could have made money off of that. And I fully agree that it is actually a better use of a name than many of the things that are in the current queue.
All right.
I'm sorry, in the current queue for special names, not regardless of other ones. But we have a bunch of special names, and some of them are very questionable. And this one, I would say, is not.
Mr. Hoffman, let me interrupt you here. I asked that you take my word for the fact that the administrative difficulty was essentially the same order of magnitude for getting permission to sign this zone versus getting permission to add a reserved name at the top level. You haven't, and I appreciate that you haven't, and it's instructive that you haven't, because my analysis of of where the time is taken for us as a technical community to get things done is that in the road to reaching technical consensus, which is something you have to have if you're going to get the layer 9 folks to move, we spend 80% of our time worrying about what could get approved and how difficult it's going to be. So just as we're doing here, we are like a moth to the flame. We are burning a great deal of time wondering which thing is going to seem less controversial to the people who are not technical. Let me just say, the people who are not technical are relying on our advice. And if we can reach a sound technical consensus, then it's game over. And we should do that without stopping to wonder if this is going to be a hairball to try to get passed in some board meeting somewhere.
So I agree, and I think I skipped over something, which is when you asked about us talking on the technical part, when no one wanted to do so, I'm assuming that they're technically equal. And I think, if I'm wrong, someone should have raised their hand. So given that.
Oh, I see.
Yeah.
I raised my hand.
You do not think that they are technically equal?
I don't think they're technically equal.
Because of the one extra round trip
Well,
for .NET?
I mentioned the extra query to fill in the validation chain, but I've also mentioned that there is a non-DNSSEC situation brewing where people who are not validating are obviously not going to be aided by signing rootservers.net, and they would be aided by moving these names into the root zone.
Thank you. I didn't get the last bit, and I'm not sure that I do, but doesn't matter. You can't explain it anyways. Okay.
Warren.
So, one of my concerns is, and I was trying not to go down this rat hole, but if we were to do something like this, you then end up with now we can make more changes to priming responses. Let's put other changes in there as well. You know, my new technical change that I would like for whatever reason, because there is now more space. And now we've got another set of issues that we need to start dealing with. And yep, those aren't technical, and so that's why I was trying not to open it. But I'm scared of that can of worms. I'm a coward. I'm happy to admit that.
I think we're all scared of that can of worms, and I myself often make engineering judgments based on salability of the resulting product. So we're not completely wrong to be considering those matters. And if we truly were talking about solutions that were roughly equal in their technical cost and technical benefit, then I would say let's look toward the saleability in order to determine which course to follow. But, you know, I'd also like it if more often we would ask the question, if we didn't have those constraints and if we didn't have the system as it is and we had a blank whiteboard, would we draw anything like the current system or would we draw something else? And is the reason we're not asking for that because of administrative fear, inertia? You know, I'm happy to keep all of that stuff in mind. What I don't want us to do is to try and argue about the saleability.
We could address the saleability thing by having it be x.rootservers-net, and now you have the same length. Actually, with the extra label, so it's --net or something, and then it's two dashes to account for this dot label or something, or root servers, but something where we have the same length, and now we don't have to have the other discussion, right? If you choose a longer TLD.
In fact, x.root-servers would be fine with me, because that string is only going to appear once, and everything else will be a compression pointer. So we have 63 characters to play with in a literal label, so I'm happy to use 62 of them if you want. So .root just struck me as the short thing, but if we made it .root-servers-net, fine, whatever. Edmund.
There's a difference there. Not the ICANN.
Let's get this man a microphone.
All right, let's just.
Oh.
There's a slight difference there. You earlier mentioned whether .root would have gone through the new GTLD process. Right now, based on the ICANN rules, it is not a reserved name. So that's one of the names that I was very surprised that nobody applied for in this round. But root servers is in the reserved name list based on the ICANN policies right now. So there's a slight difference.
That's not slight, that's huge. If they've already reserved it, then that's like free. Anyway, so I wanted to bring this up. I wanted to have the discussion we just had. Do we have more comments on this topic?
Well, that last. If that's the case, then I think that's quite significant, right?
I think it's huge.
So
it's not slight.
I think you should make a note. Well,
PVM.
I just had a couple of points of information. So roots-servers.net, the current thing, isn't signed.
That's right.
And it's hard, never mind whether or not it's prophylactic or whatever, seeing as all of the people who run all these things are pushers of DNSSEC, what's the difficulty with signing it? Never mind whether or not that gets you to where you want to be. I'm just curious why you don't do it as a show of support for DNSSEC. Okay,
so that's a history question, and I was there, and I can answer. The others who were there will keep me honest. DNSSEC, on its best day, is a new source of reasons why queries fail. Right? It doesn't add value to successful, correct queries. It subtracts value from queries that could have succeeded but found some reason not to. All it is a new source of error, period. That's the whole value proposition for DNSSEC. We want more failure in the DNS, therefore we're adding all of this stuff in order to make sure failure happens reliably under certain well-understood conditions.
This really doesn't sound like that it's good for you kind of argument.
DNSSEC is not good for you. The only good thing about DNSSEC is what it protects you from and in what it makes possible, right? So Hoffman and some others have been working on DANE, which I consider to be a vital future for the internet because the X509CA system makes my skin itch and I want to see it die in a fire. And I think DANE is a way to do that. And we can't have DANE without DNSSEC because we can't get enough confidence in the results obtained from DNS transactions today. So yes, when we add new sources of error, we do increase our confidence that if none of the new sources of error triggered, then we can have more faith in the answer we got than we did before. Nevertheless, it is very much a save money, not a make money proposition in terms of saleability. And we did not think, those of us who were last seen arguing about this, that adding new ways for rootservers.net to fail had any upside at all. Because if they were wrong, then what you would end up with is going to some root server that had some zone that was not the root zone, or it was at least not signed by the ionic key. So the same argument that caused us to think we didn't need to sign the NS records at the bottom of zones or address glue at the bottom of zones caused us to think there is no reason to sign rootservers.net. We have since learned our error. Now we have to reconsider that decision in light of new information, and we're doing that. In fact, I think we were wrong on all of it. I believe that we should have signed the NS records in the parent. We should sign the address glue in the parent. We should demand that all address glue be present in the parent in order that we don't have the problem of canonicalizing a zone that does and does not have address glue and somehow getting the same zone hash. There are a lot of things we should have done differently in DNSSEC, and this is one of the big ones. We're already on V6. No, excuse me, V9. DNSSEC took 16 years because every 2 years we thought we were done and started over. So at some point we decided that, okay, we just found the thing that's been 2 years since the last time. We just found another thing that causes us to want to start over, but we're not going to. And so everything that's happened since then, we've just decided to live with. I shudder to think what it would have taken, what would have happened to the internet if IP version 4 had taken 16 years to argue about. ATM, yes. Thank you. All right, anything more on this topic? All right, we're coming up on noon. I would like to sit down for a moment, so let's do shared zone or local shared DNS caching policy from CNNIC. You got the slides?
Yeah, that's it. Does it work? Yeah, it works. Okay. Thanks, everyone. I'd like to make a proposal for the, we call it local shared DNS caching agency. First of all, I'd like to give some comments for the drafter, Paul Hoffman, and another drafter from Paul Vixie. Anyway, yesterday I just repeated many times that to Hoffman that I really love his draft because it really inspired me, and it reminds me of the importance of the recursive. Excuse me. Yeah, it reminds me of the importance of the recursive server, and it tells me that the recursive server could do a lot more than just being a simple cache only server, and the authoritative service could be delivered to the local community in some more efficient way. But my concern is that if massive recursive server all apply this, draft, maybe huge traffic will be created for the root. And I think only some professional companies like Google, Alibaba, or Kinet can have the full ability to well apply the scheme, not all the 2 million or millions of recursive servers. For Vixie's draft, and from my perspective, to my understanding, I think it is an alternative index for recursive server to find the JSON file. Anyway, I think any casting is a small problem, because just like I forgot who mentioned that, we just leave this problem to routing. it is not a mechanism within the DNS protocol. We just leave the problem to routing. Let the routing help us to help us. And this is one concern. Another concern is that I think POVIX's draft could be extended in some way to be a universal solution, which provide DNS cache service for all authoritative name server within a network, or we call it within autonomy. VIXI raised a saying that internet is the network of networks of networks of networks, or let me put it in this way. I think internet is an ecosystem which is from the community to the community and by the community. And it is consisted of LAN, campus, ISP, NSP, IXP, and core. Anyway, I think within an autonomous network, diversified multi-recursive servers are deployed. And for some concerns, the autonomy needs a shared, I call it local shared DNS cache services. Maybe it is because the capability concern, which is not all operator, I mean recursive DNS operator, has the experience to properly manage the recursive service. Maybe for the privacy concern, the recursive servers are only visible within the autonomy. Maybe for the traffic concern, to decrease the traffic caused by the redundant queries. Maybe for the latency or performance concern, especially for those most visited zone. Maybe for the DNS concern, because not all recursive servers support the DNSSEC. Then they need a local trustworthy server to tell it, or to help them to find out the final result. Maybe for the security and the surveillance concern, to decrease the middman attack or monitoring. So anyway, my conclusion is that a cache agency of designated NS is wanted. Actually, I don't know what's happening in the rest of the world. Actually, in China, some ISPs has taken actions. They taken actions. They cache the zone file for traffic concern and emergency and for emergency services. And some free recursive service, they cache as most frequently used zone file already. That's what's happening in the real world. So my suggested solution is that, next one, okay. A local shared DNS caching agency or service could be set up to cache any zone file of an NS, of course, with the permission of the NS administrator. The recursive server send the queries to this agent first. It fails to the original target then, or send the queries to the agent as an emergency alternative. Actually, I think it is a flexible mechanism could be designed, and this agent only works within autonomy. Provide this service within the autonomy. And it could work at unicast address to get avoid of the bad influence of the anycasting. And though loss of data is unavoidable, no matter in Hoffman's draft and in Vix's draft, I think this problem is really unavoidable. But a notify mechanism among the agent, among the recursive, and between the authoritative servers could be designed to minimize it. So the next thing we need to do is really a survey report about the actual market deployment of local cache service. It is needed. We will do that. And then we probably will try to give a draft to DNSOP. I think it's really, I can call it it's a new idea. Actually, it's definitely not a new idea. Many organizations and many companies that do the same thing in outside this meeting room. And let's take China Telecom, for example. Actually, in every province in China, they will deploy 2 to 4 recursive server in each city. And these servers will, some recursive servers send the queries to the forwarding server. Okay, some servers send the queries to caching-only server, and some recursive server just resolve the request directly. And I just discussed this problem with Alibaba, with Alibaba's engineers at the break. It is said that due to the uncontrolled computation, some some companies trying to steal the traffic of DNS to make money. So what I want to say is that the local ISPs and DNS service provider has do the same thing, okay, in their own way. But there's no such a standard way, or we call it the best practice suggestion, which comply with the spirit and the principle of Internet. And I'd like to remind that the foundation of the DNS, or including the root architecture, has been weakened due to this unordered computation. So without the full support from the recursive server or from the recursive community, the actual DNS operation is not what it looks like in the book. Every year we hire new employees, and I just give them a book of DNS and bind to, okay, read it, and you will have a full understanding of what DNS is. But very soon, they were found that the real world is not looks like in the book. So my suggestion that, okay, maybe this is just a simple. My suggestion is pretty simple, but what I want to do is that we need to standardize or regulate the recursive service behavior in some way, in the draft or in some best practice document. That's it. Thanks. Yeah, any question?
So, for many of us who operate disconnectable networks, I, for example, have a network on top of a mountain that is a Comcast business link that is not always available to me. I have hardwired my recursive servers so that they are either also a stealth secondary for each of my zones, or I have got what Bind calls a stub configuration that causes it to keep hot in cache what the NS records are and what the A records and so forth are. And this works to the extent that you can disconnect the link leaving my house, and I can still reach the things in my house that are named and addressed in my house. But it is painful. It requires that every time I add another name that something might be known by, I have to make sure that the parent of that is part of this configuration. What I have long wished to do, and what I at some point thought I would cause Bind 10 to do, which is now dead, but would be to automatically share the information between the local authority servers and the local recursive servers so that they would become aware of each other through some kind of automation rather than by static configurations that I would have to maintain with my own 10 fingers, which are unreliable. Does this fit well with your use case? In other words, is this a problem that your draft is going to propose be solved?
Well, I'm not sure. Actually, I'm not sure I will give a perfect solution to solve this problem. But before that, that's why I said a survey report is needed. I really need to get every, every case in China, at least in China, to try to find out what the company or internet companies or some campus network administrator are doing. Then I will try to give a solution after the analysis job. it,
Sorry, could you explain a bit more? But you mentioned someone in a competitive situation, someone sort of stealing the DNS traffic.
yeah, sure.
What does that actually look like?
Try
I
to.
don't understand. Sorry.
Okay, try to steal the DNS queries for some, advertisement banner and just transfer, redirect it to the another advertisement banner, something like that.
So, a follow-up from your question, isn't that what DNSSEC is supposed to solve? And, isn't this hey, look, if there are actual issues here, you should be doing DNSSEC, and also specifically ignoring DNSSEC for your own competitive advantage is uncool.
Yes.
That seems like the message, not a technical thing. But I must admit that there's a fair bit in your presentation which I haven't fully processed yet, when I see a draft. I do want to make a correction to, I think it was your first slide, or
Yep.
a clarification update. I think it was your first slide or
This
second
one?
slide. Yes. The first concern for the Hoffman and Kamari thing, I think that there should be a significant decrease in route traffic. If every route, or if every recursive server were to do this, each one would do a sort of 1 meg zone transfer twice a day. All of the junk queries then, though, would never hit the route. Also, most caches end up with fairly much all of the TLDs very quickly because, there's spam and everything else. So instead of doing it in a bunch of individual queries, which each are significantly sized,
Okay.
you get it once. There's no more junk. And so, but that's just a minor little bullet point update, not really important to the meat of your presentation.
Yep, thanks. Yeah, we will, double check it. Maybe the traffic will be decreased. Considering when we talk about DNSSEC, I raised this question is really because that the DNSSEC is really not a compulsory requirement for the recursive servers, and at least in China, only less than 1% of the of the recursive servers support the DNSSEC.
And to follow on that, Warren, you said, well, they should just use DNSSEC, but that means also that the zone that is used in the advertiser also has to use DNSSEC. And I think what you were indicating, this is probably, you wouldn't want to say we can only protect you if you add DNSSEC to your zone. So there's a question of the recursor doing it. As you said, we're at 1%. And I would suspect that given that, of the advertisers involved, that might be less than 1% even. So I'm not a big fan, Warren, of we've already given you a way to protect yourself. If you don't do it, tough luck. That doesn't work for me.
I wasn't saying that should be the only answer, but if that is actually a big concern and it's causing competitive issues and commercial issues, perhaps it would be useful for the people who are being affected to, for example, say, this was my traffic, I signed it to show it was my traffic, you futzed with that.
Yep.
I will now take you
Sure.
to court, or
Absolutely.
complain to
Yep.
somebody. There
Yep.
are other ways which provide more privacy enhancement.
But I think and the reason why I'd raised my hand was not just to disagree with you or to tell you to turn off your cell phone. Was one of the further slides that you had, because I do, by the way, I'm very much looking forward to your survey. If you do such a survey and you do it soon, you will embarrass many other countries that have the same amount of recursive resolvers doing things like this where no one has surveyed them. Terry, I'm sort of looking at you, since you had said you had done that a while ago, and we all believe that no one ever changes configuration. So you might go back to some of your previous employers and say, remember that config file? Do you still have that running? But then you followed up by saying that this would definitely be on not on Anycast, that it would be on Unicast. Mm-hmm. And I'd like to go back to Paul Vixie's potentially dangerous idea of that a Unicast address that's actually on unroutable. So if this really is for local, you keep saying local, and of course, the word local in English and probably in most other languages is quite ambiguous, you know, and what's seen, I'm hearing that it might be ambiguous in Japanese as well, but local can mean only the people who are on this sort of network segment can get to it. So this might in fact, you know, totally match what Paul was suggesting, or I don't know if he was suggesting the bad idea that came up, which is to have those as unicast addresses, but to be unroutable past whatever the L in local means.
Yep, I said that it could work as unicast addressed, but actually originally I'm planning that it is really a service that works within a local network segment, which covers the networks served for the end users within this network. That's it.
So, one of the big problems with internet routing technology is that you cannot guarantee non-routability. So, to the extent that we wanted an unroutable address for this purpose, we could not use any of the existing RFC 1918 space because people have already generally carved that up. They're already using that the way they wanted to use it. So we'd have to sort of add some more address space to the pile of non-routable space. And I think most of you in this room know that packets destined for that address are going to be in the Internet core. Packets sourced from that address are going to be in the Internet core. And routes advertising the reachability of that address are going to be in the Internet core. And in the absence of the Internet police force that could somehow go with wire cutters and disconnect the people who do those three things, some of us might do all three, we can't guarantee non-routability. And so it becomes an extremely dangerous design primitive is to assume the existence of something which cannot be guaranteed.
Just to be clear, I wasn't assuming that.
Okay.
I was making it as a suggestion.
Yeah.
I don't think that assumption is required.
Okay. Go ahead.
I agree. Just one we said we should a survey for that. Something already happened in China. As I know, one is the local authority cache, like in Cernet. Another is local recursive survey cache. It's happening in China Telecom like that. So we think not only in China, maybe other places already happen. So not just do new things. Just we should survey what are happening.
Yeah, and let me add to that. I agree that a survey of this would be very instructive to those of us who think we're going to build relevant technology, because we need to know what's going on so that we can figure out what we got wrong. For a long time, the IETF said that NAT was bad and end-to-end was good, and the world ignored them and built NAT. And it would have been better, I think, if the IETF had said, well, this is inevitable, so what's the right way to standardize it before it gets out on its own? I'd love to see the survey results. So thank you for this.
Hi, Wei. Okay. Hi, Wei. I have a suggestion. You say you are going to draft the document, right? So, I have a concern. The previous slide. Okay. You say the LS DCA could be set up to cache any zone file of AES with the permission. So, by comprehending your expression, I just have the implication that the local shared DNS caching agency will have just the part of the zone, right? The many of the zones. So if there are two local shared DNS caching agencies, maybe some content have overlappings. So are you going to trying to solve the problem relating to intercache things or the conflicts?
Excuse me. What is the overlapping?
Overlap.
Person?
I mean, there are two local shared DNS caching agencies, and each of them have a part of the.
Well, when I say with the permission, I means it is a no matter it is a technical support, or I mean this permission could be reached by protocol packet communication, or by the contract. Anyway, I don't like this agent works without the permission or without the awareness of the NS administrator.
Okay, so that's it's relating to the policy and the contract.
Some sort of.
Maybe I can give a comment, because for the GTRDs, they have some kind of agreement which you need to have give permission for others to download the room file. And then for CCTRD it's different. So I mean that if you get permission to access CCTRD, maybe you need to have some kind of it's contract agreement or something else. Yeah.
Okay, thank you.
Andrew.
I was first? Okay, well, people do think I have a big mouth, but I don't know, I need two microphones. So one of the discussion about local and this thing about caching with permission has suddenly given me the willies. One of the truisms in computer science is that cache invalidation is hard. And this strikes me as a tremendous opportunity to add a new layer of caches that are going to present, sort of ability to get sort of weird inconsistencies and so on. And as an operator, one of the things I hear all the time is that people are the naive view that a lot of our customers have anyway, I don't know about yours, about the way the internet works is that they publish a new zone and the entire internet has it sort of immediately that moment, and everybody's forgotten that TTLs count. We have a number of customers who set their TTLs to 30 seconds, and the only reason they set them to 30 seconds is because I keep telling them, if you set it any lower, people are going to ignore you anyway, so stick with 30 seconds. I don't know how long that's going to be true. And so it seems to me that what we've really got here is a pressure for additional sort of authoritative name servers that are not quite authoritative. That is, they're not globally authoritative, but they're sort of locally authoritative, and you're going to have some kind of agreement. Mm-hmm. And this suggests to me that maybe what we need to do is think about some new way of expressing, no, you can do this sort of authoritative name server stuff here. I mean, one way we've done that, of course, is sort of massive Anycast deployment. The other thing that worries me a little bit is we're not being completely clear about what we mean by local. A couple of years ago, I had a rather uncomfortable discussion with somebody from the Zigbee Alliance who came and told us that they thought they had a solution in MDNS for site name lookups. And it was only after they'd published the specification and put it into Silicon and shipped it out into the world that they realized that what MDNS does is works on the local link. And the local link on your network inside your house probably doesn't include your power company's meter. And they really hope that it doesn't include your power company's meter from the power company's point of view. And you, of course, don't want your power company just kind of randomly coming into your house and messing with your appliances. And so suddenly it turned out they had this big problem. And their answer to this was, you need to go away and fix MDNS for us. The IETF has actually got two working groups working on this in parallel, as nearly as I can tell, both of which are deeply confused about this. So I really want people to pay a lot of attention to this local meaning because of what Paul was saying. People have a technical meaning which is really, really bounded by the network. And it's not going to be it's not going to be satisfying to people if it turns out this is all local link or something, which I know is not what you meant, but I think a lot of people are going to be confused by this otherwise.
Yeah, can I just amplify again? Sorry. The concept of local, perhaps, I don't know, at the private, it may be a better way of
let me do an explanation.
This will be the last comment.
yeah, and that's it.
The local here is administrative region. And it is a compares and company, our ISP, our province.
Do you have any
No.
slides?
No, no.
Okay. All right, thank you.
Thanks.
I remember there was a signaling protocol in the IPv6 packet. There were some addresses that were allocated to be campus-wide or something like that. And they were eventually taken out because no one understood exactly what they meant. One thing I will say about the internet being a network of networks and so on is that each of us has a different horizon. Each of us sees the network that we are able to configure and have behave cooperatively as being, you know, according to our station in life. I have total authority over the network in my house, but Comcast won't listen to me, so that's the top of my umbrella. Anyway, I appreciated that presentation. We are down to our last few minutes before lunchtime. Warren, can you put up the slide I gave you? So the sense of this is just to kind of unwind a little bit of the damage that was done in the early days of Bind, where because Bind had one big data structure that was sort of one big tree-like thing. This is Bind 4 and Bind 8. And again, Bind 4 had a 100% market share at one time, so this was quite important. Anything that was broken about, everybody else just had to live with. So this idea of what we currently call a mixed mode server, but which PVM correctly identifies as the way, you know, classic DNS model, where you have a data structure that, thank you, a data structure that has both recursive and authoritative data in it, was poorly implemented by Bind. It mixed things up, and Bind version 9 gets it right. By having a table of authority zones where each one of those has their own table of names, and then there's a separate table of recursion. And, you know, the problems that we learned about in Bind version 8 very much dictated the structure and the logic in Bind version 9. Nevertheless, during the time that Bind 4 and Bind 8 had put big fear into people about authoritative and recursive in the same server, a lot of people said, we just can't act this way anymore. We need, any given server needs to be completely authoritative or completely recursive, because we don't understand how to mix them, and probably we didn't need to go that far. We may have thrown the baby out with the bathwater, to use an aphorism from Western culture. Anyway, during that time, DNSSEC came into existence variously, and so the way the DNSSEC validation model looks is the top of the two data flow diagrams you see in this picture, where I'm showing with that black dot where validation occurs, which is that if the recursive makes a query and gets an answer, then it can be validated when it comes in, because you know it's a message. It came as a message, and you can validate the contents of that message with the signatures it comes with, the signatures you have, and the signatures you can fetch. And you either have the ability to make a trust chain from this answer back to some trust anchor that you trust, that's hard-coded into you or maybe written on a file on your hard drive, or you don't. And the problem is that the DNSSEC specification, as I understand it, does not describe the point at which validation would occur in what we now call a mixed mode server, but again, to be fair to PVM, was the classic DNS model, which is where you have some authority data inside of your data structures, and you don't have a message so much. There's no message by which authority data is delivered to the validation engine. The validation engine can simply reach into the data structure and get whatever data it needs. Now, in the case of a root zone, you don't have a problem because the data that is in the root zone is directly verifiable using the trust anchor that we presume this RDNS, this validating RDNS has. And so data coming out of the root zone structure inside of the data structures of that mixed mode server can just be checked against that trust anchor. On the other hand, if you are authoritative for something further than the root, what's not made clear anywhere in the current logic of DNSSEC is whose job is it to validate it, and at what point in your logic will you validate it? I've put 2 black dots as the 2 obvious places where this validation is going to occur. And what I would ask you to consider is, let's say that you're a server for Vix.com, and so you really are an authority server. You really did fetch Vix.com from somewhere. And so you consider it authoritative. You're setting the AA bit on answers that people ask you about Vix.com. But the question is, do you consider it valid, right? Because we don't necessarily validate the contents of the zone using the zone's own signature. And even if we did, walking the zone would not give us any kind of signature coverage over the NS records at the bottom of that zone, if any, or the address glue at the bottom of that zone, if any. And so you can't validate it. You can't decide whether this data is valid just because you happen to transfer it. What you need to do is to walk the zone from the trust anchor you have at root to go find whether, find the COM server and get its DS records for Vix.com. And if the data that you're pulling out of that data structure happens to fit the signature and the key that is validated by the COM or the COM DS record and so forth, then and only then would you say that this is valid. That's not written down anywhere. And I want to point out that when we talk about doing this in the classic DNS model, which we mistakenly nowadays call the mixed mode model, is going to require that somebody put some thought into where that black dot goes. And there's probably going to be a small RFC that amends the DNSSEC protocol to say, by the way, mixed mode isn't as bad as we thought, and this is where the validation has to happen. Anybody have any observations, corrections, concerns? PVM.
Yeah, I think you're right. I think one of the things I keep asking people is, why is it okay to send a query off to the loopback address, or God help us, a local address, or maybe even a routable address, and get an answer back, and you can't just reach across memory and do the same thing. So, I think people who don't believe that mixed mode can work should just figure out the answer to that question. But I think there's another issue in that you may have different ideas about which trust anchor you believe in the stub, so that you may choose to say that Vix.com should be validated according to a trust anchor that you have, regardless of what ICANN happens to say. And so you have to figure out how to deal with that in the presence, and the fact that if you have one zone, you may have more than one, and you have to figure out what's the order in which you search those. So I think that you end up with a search tree per trust anchor that you choose to believe above all others.
Well, let me point out that if he doesn't see us coming, we might be able to capture Rob Austin and get him to write this RFC. But if he sees us coming, he'll be running down the street to avoid it. Andrew.
I don't think that the arguments that I buy for why mixed mode is a bad idea are not that it's not a correct part of the protocol, but rather because the implementations are so hard and so fraught with difficulties where people get things wrong that it's just engineering prudence not to do that, and therefore you should run stuff in these 2 different modes, or and just keep them apart. It's really fundamentally the same argument that we have for don't build your operating systems with big giant single systems that have everything doing it. All of your video things shouldn't be right down in the kernel and all that kind of stuff. It's the same kind of prudence argument. So I'm not sure that this is really a thing that we want to change the advice about, not because the computers can't do it, but because the humans can't do it.
Well, let me say that at the moment, it's not prohibited. There isn't an RFC that says don't do what we now call mixed mode, and there isn't an RFC that describes how to do it correctly in the case of DNSSEC. One of those RFCs needs to get written. My reading of the tea leaves, looking at the current larger DNS protocol development community, not just those in this room, but the larger set of them, is that we're more likely to get the latter than the former. And I just want to note that so that anybody who talks about how the Warren, the Kamari-Hoffman draft should have specified this mixed mode thing, one answer is, well, we wanted it to work on servers like the NSD unbound combination that simply don't have this capability, so we need a message passing method of configuring loopback type things. But the other is that we don't really know how to do validation. I know how Bind 9 does it, and Bind 9 probably gets it right, and that may be just all we have to do is write that down, because some pretty smart people, not me, that is to say, came up with some logic there. But I'm pointing out that there's a missing piece of documentation here that either says, don't do this, mixed mode is dead, or do this, and if you're going to do DNSSEC, don't forget to do this, that, and the other thing. Warren.
I'm just relaying a comment from Oliver Goodmanson, who I guess is watching the stream, who said that original DNSSEC design had validation on mixed mode servers, but operators did not like the possible load. What that's worth.
Okay, well, then perhaps there's some old NROF documents we can look at to get some ideas. Thank you, Oliver. All right, we are at the limit of our time. It's almost time to get out of here and go have lunch. And so I want to do some closing remarks, which is to say, a small number of you remember me when I was a young punk coming into this field. I had long hair. I was even more insufferable. And it's been, God, I don't know, 28 years since PVM flew up to my house and took me out to lunch and said, there's this thing called the IETF, and if you're going to be working on Bind, you really need to be going to this. And I said, but it sounds like a complete waste of time. And he talked me into it, and I went to the Canada IETF, and that's where I first met John Postel, for example. So thank you, PVM, for getting me into this. But I just want to say that if somebody had used a crystal ball and somehow told me, yeah, so 28 years from now, you're going to be able to sort of arm twist a bunch of people to all fly to Hong Kong, and a bunch of them are going to be root name server operators and CCTLD operators and name server authors and RFC authors, and they're all going to come because you ask them to, and you're going to have great power. Please use it responsibly. I would have said, no, that's never going to happen. So the honor you bestow on me by having been willing to come here just because I asked you to, and because I told you it would not be a waste of your time, is huge, and I am humbled by it. So let's thank our sponsors, CNNIC and ZDNS, for getting us these facilities. And some of you are going to come to the ISOC Security Summit tomorrow. If you have not registered, please contact myself, Ping Wong, or Pindar to get the URL for registration. We don't know currently when and where the bus is going to show up, but it's at Cyberport, which is on the other side of the water from here, so you're going to need to use a bus to get there. It's in the afternoon. So those of us who are staying for that have the rest of today and tomorrow morning to play in Hong Kong, and I can't think of a better time of year, better weather, better air quality to do it in. So I am excited to have some time to enjoy this great city. So thank you. Let's have lunch.